So, thank you very much for your time today. It's encouraging to see that there's a growing interest in fuel displacement within the mining industry. Understandably so, because often the power generating costs are the most expensive, or one of the most expensive operating costs for a mine. My background, I'm actually a mechanical engineer, and I've spent the last 15 years building power stations for mining communities. Lived in a mine, worked in mines. So I understand about not just the various power solutions that mines currently have, but also the operating load profile and the technical challenges that you have, and also the critical dependency of the power generation on site. So, but while some of you may have had some introduction into hybrids in the past, my experience is within mining, most people are still relatively unaware of what a PV hybrid project is and what a solar power plant can do. So for the purposes of today's discussion, I'm going to keep it at a very high level just to have some very basic scenarios to illustrate the concept. However, at the back end of the presentation, there are some more complicated illustrations of how the control system methodology works, just to encourage those that are probably more skeptical than others that there are a lot of smarts involved and even though we're a solar company, we certainly do have internal resources and strategic alliances with others to accommodate a lot of the challenges that are faced and specific to mining companies. So if you have questions that aren't covered today, we've got a booth at 3610. It's listed in the chart. Please come past, say hello, swap business cards, and we can address your specific concerns more specifically. So anyway, in terms of introducing First Solar, so First Solar is one of the world's largest solar companies. We develop a very cheap thin film technology which finds itself particularly useful for utility scale projects. So we tend to specialise in actual power stations rather than putting them on rooftops. Now, as a result of that, we've actually got over 8 gigawatts of panels installed, and we've got 3 gigawatts of panels under contract as well. And in the last 15 years since we've been listed, we've financed approximately, or assisted in the project financing of $9 billion worth of projects. So we're largely regarded as the strongest, we have the strongest financial stability and most bankable solar company in the industry. And we cover all of the segments whilst we focus on the utility scale. Obviously today we're talking about the fuel displacement market as well. But we're expanding into the very small community, the areas that have no power at all, and also we're merging into the the limited space or rooftop market as well. And finally, this shameless self-promotion will end at the end of this slide, but basically one of the other values that we provide is that we're a full service provider. So in the end, First Solar has the ability to provide everything from the very beginning, identification of opportunities, the feasibility study, the verification of it, the optimization of the design, the full delivery of the project, and also possible asset ownership and the operations and maintenance as well. So we recognise that mining companies have their special expertise, which is the mining operation, and the power generation needs to be delivered by a competent full service provider, and that's definitely something that we focus on delivering. So if we talk about fuel displacement specifically, it's a market that's emerging, and the reason that it's emerging is because of costs. So you can see from the chart here, the green triangles represent the levelized cost of electricity from solar power over the last 10 years. They've effectively halved because of, primarily because of panel cost reduction. And you can see in the blue line, that's just an indice from the WTI crude oil price over the same period of time. Not only is it trending upward, and everybody's expectations is that it will continue to do that, it has an extremely volatile profile, which means that projecting costs for the life of a project is an incredible uncertainty. And that's an enormous risk when you look at the fact that it's one of the biggest costs for the operation of the mine. So it's got to the point now where the reduction in cost from solar is competitive to diesel. It's actually competitive to a lot of different fuels. So what you may not be able to read in the back of the room is that on the left-hand side we've got coal and nuclear. We've got the cheapest forms of power generation to date, and it progresses in terms of cost. And we go up to combined cycle, open cycle, depending upon different parts of the world with different costs of fuel. And finally, we're looking at diesel, where the costs are substantially higher than the levelized cost of electricity that we're currently delivering with the first solar power station. In fact, the only projects really that are still cheaper on the levelized cost of electricity basis from the first solar power plant is your coal, nuclear, and some of the more efficient combined cycle gas turbines on cheap fuel. Oh, oops. A bit slow in responding. Now, one of the unrecognised benefits of solar is that it has a very strong technical compatibility with thermal power generation. So one of the reasons for that is that your thermal power generation tends to derate, or it always does. It derates in higher ambient conditions. And it's precisely during the higher ambient conditions, which tends to correlate with the middle of the day, that you get the maximised output of your PV. So whilst one power station is reducing in its output, the other is compensating. And it's compatible with all thermal power generating technologies. It really doesn't matter. There are some of these are a bit more compatible than others, but the projects that we've been looking at, it is largely arbitrary. So talking about the particular solution that we provide, we don't recognise, or we don't consider the solar plant as being installed capacity. The solar plant is to complement the existing installed capacity. The solar plant simply provides a secondary source of fuel, which means that if you have an existing power station, we don't expect to displace, replace, reduce, impact at all the current configuration. And obviously the costs of your existing thermal asset will remain, and then you've got the additional cost of your PV on top of that from a capital cost perspective. But the overall reduction in fuel, the fuel cost saving alone, makes this an economic proposition. So there's three main benefits that we've identified with the PV hybrid. Now the first and most important obviously is your economic, and of the economic benefits it's going to be the fuel cost saving. Now the fuel saving has two benefits. Obviously it's your costs, but secondarily it mitigates that volatility that we saw with the oil indice. And the other benefit is that PV is incredibly scalable. If there are concerns about the technical compatibility, it's easy to put a small amount in, technically prove it, and in some ways the expansion of the plant may be financed by the fuel cost saving. If you put in 1 megawatt, for example, you're going to have a fuel cost saving, and the fuel cost saving generated by that 1 megawatt can assist in the scalability of the next phase of the plant. So it can be financed from operating costs. But there's often unrecognised benefits from operational perspective as well. So with a reduction in fuel consumption, you're going to increase your local energy independence. And that's particularly important with areas that may be exposed to weather conditions, arduous weather conditions that can impact the ability for fuel to be delivered to site. And also you're reducing your fuel transportation logistics. But by having a reduction in thermal plant operating time, there is the potential to extend the life of the existing asset, the thermal asset. And you also increase its redundancy. There are some plants we've looked at where the connection to the grid is rather unreliable, and by having a power plant there by PV, obviously it's only running during the day, but it still gives you additional redundancy that you wouldn't otherwise have. And if you have a thermal plant on site, it gives you extra redundancy as well in case one engine goes out, and it can improve the operations and maintenance scheduling and reduce your operations and maintenance cost. And finally, as you would expect with every PV or any environmentally friendly technology, it has all the environmental benefits, so reduction in carbon dioxide, possible credits from environmental green trading schemes, and also it's very good for community and PR. Mining companies, other operational processes can have issues with regards to getting local community advocation. And also, if there are bureaucratic or legislation barriers to getting expansion on existing or old brownfield power stations because of pollution, this is one way to expand that without those issues. So to very simply illustrate how this works, the blue on the right-hand side represents the diesel load profile, or just the load profile for a 24-hour period, peaking in the afternoon. We've got the two diesel generators providing the energy, and then along comes the PV plant, and it's just a very small contribution of extra energy source. Now, again, to very simply illustrate this, if you have a base load power of diesel, it comes through and it's essentially seen as a negative load. So there are complications that need to be considered. In fact, the design process is very sophisticated, but for low penetration solutions, it is as simple as the PV plant is acting as a negative load, as though the power station witnessed somebody turning off a whole bunch of air conditioners or a whole bunch of loads. A conveyor belt suddenly turns off. That's effectively the solution. And it's highly scalable. Now, if we're looking at different scales, it's important to understand that each one has its own particular nuances that need to be considered. So if we look at the arrow is just illustrating the various stages of penetration. Now, penetration, because hybrids are a new concept, the market doesn't really agree on nomenclature yet. So penetration in this purpose is demonstrating the instantaneous load, what's happening at that particular moment. So if we're looking at a situation on the left-hand side here, for example, and we're looking at a very small amount of penetration, we're saying 10%. Now, if that's the case, you don't really need a control system at all. It's much like having PV panels on your rooftop and it's feeding into the grid. Anytime the sun shines, it exports the power. That's fine. But once you start to increase the penetration, you really need to start looking at your control system solutions. So the next stage is anywhere from 20% to 30%, depending upon the specifics of that site. We need to look at what's called a passive control system, and that's where we don't touch the digital master control at all. The existing power station remains as it is, but the control system of the PV plant anticipates the operating methodology of those engines, or gas turbine, the plant. It does it in such a way that it ensures that we curtail the PV, if required, to preserve sufficient spinning reserve in the engines to accommodate whatever volatility may be experienced in the load, and also a possible environmental interruption due to cloud coverage. Now, the next stage is really where you want to be looking at doing it. The lead control system is the brains of the power station. It's what interfaces with the power station and the rest of the load. Ultimately, what you'd want to do is integrate the PV plant with the digital master controller of the incumbent power station. And we've been working in cooperation with the OEMs, and there's a very eager participation program for cooperation to occur. And as you can see, that's required when you're starting to get to a higher penetration level, let's say up to 60-odd%. Now, ultimately, at the end game, what everyone really wants to do is to displace diesel. So what you want to try and do is displace as much diesel as possible. So in the future, the idea is to get as much penetration to the levels of possibly 80%. And with the inclusion of battery technology, we'd like to push. Is this going to work? We'd like to try and see if we can displace diesel entirely at certain periods of the day. That, just looking at the final solution first, and we'll come to batteries next. The total site control is where some clients have been adventurous enough to explore the possibility of doing demand site management, so that if the sun is shining, rather than curtailing it, we start to turn on non-critical loads, or we have storage devices. For example, you may have a water pump that's 50 kilometres away from the mine, and rather than running it on a 1 megawatt diesel project, you put 2 megawatts of PV and you pump the whole thing during the day, and you build a storage tank on site. The building construction of a storage tank is a lot cheaper than it is to run a thing on diesel, so it makes economic sense very quickly. But we also have non-critical conveyors, camp loads, for example. If the sun is not shining, rather than firing up the diesel engines, we can look at load management systems which optimise the energy conservation. At this stage, I don't expect many willing candidates to allow an energy company to meddle with the operations of their mine, so that's sufficient. Now, batteries push the penetration up with every single one of these cases. At this point in time, battery technologies are still very expensive. Apologies to any battery representatives in the room. But for load shifting purposes, we're still needing to get a price reduction on the batteries. But technically speaking, it does provide another string to the bow. However, batteries have two opportunities to contribute to a hybrid solution. One is load shifting, as you'd be familiar, storing it for later. The second is what you call a power application, and it's similar to a hybrid vehicle where you've got your diesel engine or your petrol engine and a battery on board, and it optimizes the operation of the gensets. And by doing that, you avoid part load operation and the gensets, and you avoid an inefficient zone where there's better consumption of diesel. Studies and the modelling that we've been doing to date suggest that in certain applications that provides a positive economic return depending upon the specificity of the particular batteries. Now, when we're talking about loads and penetration, sorry, do I need to point this here or at you? At you, okay. This chart illustrates the general opportunity. And what it's saying is that on the bottom, we're talking about the PV penetration. On the very left, we're talking about zero penetration. It's what you've got already. It's the diesel plant with no solar. And on the far right, we're talking 100% penetration, where we've got all the solar providing all the energy and the diesel's turned off. And on the left, we're talking about the levelized cost of electricity. Currently, you have an arbitrary cost of X. As you introduce PV with penetration, you will see a reduction in energy costs. Overall, levelized cost of electricity, including the cost of your PV plant, the capital repayment. However, it gets to an optimum point. After that point, it starts to increase. The idea is not to get to the maximum point at this stage. Costs of technology are too high. The idea is to find the optimum point here. Unfortunately, most mining companies are only willing to put a very small amount of PV in to test the system, and that's fine to prove it up. But they're not going to realise a lot of cost savings. So what I recommend is that we look at a two-staged approach. We put in as much as required to offset the basic, stable, non-critical loads. If you've got a camp on site that has a 1 megawatt base load, we put 1 megawatt of PV to prove the system, integrate the technology, and get some realised gains with a plan to do the optimum design and get it to the maximum fuel cost saving. Now, that was the basic profile we mentioned before. In reality, mining companies often have a load profile like that, and that is a particular client we're working with. It'll go from 15 megawatts to 2 megawatts in less than 30 minutes. And so the question is, well, how big should the PV plant be? What's the optimum level? That is not an easy question to answer. And that's why you need sophisticated modelling systems, and you need somebody to take on board the performance risks. And that's something that First Solar does. Now, the design can be to optimize the reliability of the system, maximize the reduction of diesel, or just to generate the lowest cost of electricity. Or you can have a weighted average of various metrics that you want to deliver. I've got to wrap this up very quickly. This is a project we're looking at in the Pilbara in WA. This demonstrates that we're looking at, on average, a 1.25 megawatt block, which is our standard AC block, delivers about a 60 to 65,000 litres of diesel saving per month. So if you scale that up, that's a metric, 1 megawatt. If you go on 5 megawatt, 5 times 65,000 litres a month is an expectation in that region. And the idea, there's your diesel cost. The diesel's reduced. There is some solar cost, but overall the cost is reduced. And we can do PPAs, build and operate transfer, leasing program, or EPC. I don't recommend EPC at this stage. EPC means that when you ask the question, how big should the PV plant be, the answer is as big as you like, because the EPC person's getting paid on $1 per megawatt installed basis. But if you want them to commit to the design, you want them to make sure they're putting in the most effective design and basically saying that they'll take on board the energy risk of that plant. So the main takeaways: solar's cheaper than diesel, definitely. It's sometimes cheaper than other liquid fuels or fluid fuels like LNG. We can put them together, but you need a specialist in the field. It's not a simple game. Thank you very much for your attention.